Okay. Oh dear. I started the recording for once with a shell window open. How unprofessional. Hello everyone and welcome to Handmade Hero Show. We code a complete game live on stream. We are it's going to be an interesting day today because essentially what we've got is we've have it all, as Lemon Grab would say, but Fat Lemon Grab. But we wrote a ton of code over the past weekend to use a single text file input to, well, as many text files as we wanted technically, but to take a text file input and use that to sort of specify a packing set and markup for all of our assets. And we got all of that done. It didn't take very long. It was good. And we kind of, I think, did a reasonable job of it. But we never ran any of it. So we have no idea how much stuff we may have screwed up. We don't have any idea how buggy it might be. And so really what we want to do this weekend, today and tomorrow, is get all that code working, get the bugs out of it, get the other parts of the system that haven't been brought up to speed with this integrated with it. For example, now we have an open question that we want to go address. This will probably be what we do right after we get everything working here. Which is we now have an obvious place and a clean path ready for us to save changes. So basically when we do, I don't know, folks who maybe don't catch the stream every time might not know, if we actually go on here and we run the game, there's still, let me go ahead and put us in release mode so we're running reasonably quickly. You'll have to bear with me here. We have some 4-coder stuff I have to talk about as well because we're still on the old 4-coder and we're going to switch to the new 4-coder shortly as another thing. But yeah, so many things in here to talk about. So let's switch back to Handmade Hero. Let me switch to our build file here and switch us to an optimized build. Anyway, as I was saying, inside Handmade Hero, we made some tools that were designed to allow us to quickly change how we were aligning art assets and stuff like that. And so the F keys across the top, you can kind of see if I click on those, right? There's a bunch of junk that goes on here. And some of it we haven't really done anything with. There's some stuff happening in here that really probably needs to get updated a little bit. But then we've got, some stuff in here. You can see there's a camera thing that we were using for camera debugging that shows us stuff, right? And we can adjust things like the fogging distances. And that's how we tweaked those, right? It was very handy for that. And then we've also got this other thing we can do here on, I guess it's F3, where at any time if I click somewhere, right, I can highlight and let me bring it a little bit so you can see it. You can see there's a little wire highlight that kind of goes around stuff. And if I click on those things, then I can actually edit the stuff that I selected. So if I click on one of these things here, the glove or whatever, right? I can look at what is in the glove, and I can sort of get some different information points about it. One of them is just what was in the file for it. So did it have any import errors or anything like that? And what it was, who made it, did it have a name or description? We never had a way to set those before. We do now, and so those will actually come up as being set to something when we actually run our new system too, which is pretty cool. But so we've got this sort of stuff, and then the other one was this alignment points thing. And the alignment points thing is actually for editing in the game, right? Because we can change. So for here, you can see the default alignment point. I can change that, and it takes whatever the game thinks the location of that thing is, and it offsets it, right? Because we don't know, maybe the artist wanted to base the thing around the base of the glove, or maybe they wanted it around the fist of the glove, or maybe we want it around there, who knows? And so that idea of being able to create these attachment points is something that we need to edit, and we did a bunch of that. If I look at the sprite for the character that's being drawn right now, right, which is just one of our random orphans that we picked. If you look at how her textures are set up, what you can see is that actually the hot points have already been set to like attach her body to her head, right? And you can see that here where you've got these different attachment points. Here's the one that goes to its child. This is the body. This is the one that goes to the child. This is the one that goes to the world, right? And you can see that base point there is the one that goes to the world. And then this one here that goes, the base of neck, is like up there, right? Yeah, if you look at this, this one has its two-body one right where that is. So these 2 points like snap together, and that's what puts the head on top of the body, right? Now, the problem that we had before, and it wasn't really a problem, it was more of a like to do, because we knew what we wanted to do with it, but we didn't have any way to actually do it. What we had there was, once you did those edits, they got saved back into the HHA. So they are permanent, and like, I run the game again, it's always there, right? So it's being saved properly back into the game as such, right? So it works the way that we want it to work, and that's all good. But what we couldn't have done, and never did do, is rebuild that HHA, that data pack file. Because if we rebuilt it, we would have lost all of that information, right? All of that information would disappear. And so as we go forward, and we're going to be speccing a lot of these things, right? I'm going to go into that mode, right? Like if I was doing editing here and I edit this one, we're going to edit a bunch of these things. And we want to be able to save them in a permanent way that makes it easy for us to deal with. And so when we're going to be doing all that, we want those to go out into the text files that we can then check into source code control and version and all that stuff, and cut and paste between them if we need to, fix something, all that sort of stuff. We're just tying into the fact that there's a lot of text editing tools out there, right? It doesn't matter if it's text or binary in the abstract, but in terms of actually being able to work with it, having a text file format for things that are small tends to be pretty useful, because it means you can leverage all of these other tools. Like binary diff doesn't work particularly well, for example, right? But text diffs are pretty good. So all of that stuff just means that when we actually do one of these edits, what we'd like to do is be able to generate the HHT that corresponds to that HHA file sort of from whole cloth, so that we can write out all those changes and edit them that way, right? Like that's something we'd really like to be able to do. And so I need to put that back in as well, or not back in, I need to put it in the first place, because now we have a clear way that we could do that, and we'd like to have that be operational. Okay, so let's take a look at how we're going to accomplish some of these things. So the first thing that we want to do is kind of take a step backwards and say, well, all right, let's suppose, first of all, that, maybe let's just try that one step, that part of it first. What if we wanted to be able to save an HHT file out from our HHA edits, right? So for example, if I was going to go in here, like I said before, we already have this idea that in here we have like an import and save. This save feature is grayed out because we haven't made any changes, but that's the only reason it's grayed out. So, we could even re-enable it to make it so that it can do a resave in the case where it wants to. So if I did go in here, for example, and said, oh, maybe I just touched this thing, you can see that that will create an undo record, which will then mean that we could save our HHA again. If we did that, we could make it so that it saved the HHT alongside it, and then it could be our discretion whether we want to merge that HHT in or not, or whatever else we might want to do with it. And so that's thing number one, right? And there's a couple different ways that we could choose to do that, and I'm not sure exactly how we want to do that just yet, but we'll sort of talk about it as we go. So if we wanted to do that, how would we start off with something like that, right? Like how would we make something that allowed us to write out one of these files? Now, if you remember correctly, what they look like is this. So a tags file for Handmade Hero is really pretty straightforward. It's just got, here's the type of thing that it's looking at. Here's what the file name was that it came from, and here are the tags that are associated with it. There's also some additional things such as the author, description, and the HHA. Those are set by default up here, and we don't really specify them anywhere else because we don't have to, right? We don't care about that part. So what we'd like to do now is have a way of writing out these HHT files that basically produces something that looks exactly like this, so we can save changes that we make inside the game. And eventually, for all we know, we might just make a tag editor in there as well, so that maybe we never really touch these HHT files very often anyway. They're just our archival format, and we know that we can go in here and edit them in text if we need to, if we screw something up, or if we want to be able to inspect the change that we've made because something broke or whatever, we'd be able to do a diff on them. So it's a good thing to have in there. But for all we know, we might never really touch these by hand very often if we actually put in something to edit the tags, because obviously the rest of this stuff is stuff that doesn't really need to get edited much. So that's one way to think of it. Now, there's a couple subtleties here, which is that in here where we've got like block and body and stuff like that, I don't think we saved this information. So one of the problems that we'll have is we'll have to start preserving that information if we want to be able to rebuild HHT files. So in here, for example, inside where we've got the asset source file, right, this thing right here. So when we talk about asset source file, we don't actually have, you can see in here, we don't actually have the type of asset import that we actually used. Now, we have a thing that says where the assets went, that we imported, right? So that we could import them again into the same place. But we don't actually have anything that's more specific than that, right? We don't actually have anything that tells us any information about what this source file was actually set up to do. And that's going to be the hardest thing, I think, for us to deal with. As long as we don't care about vaporizing our current HHA edits, which I don't think we do because we only did a little bit of edits on them basically just to test the editor, I think it's probably okay, because every time here forward that we actually are going to be doing this, we can just store in this asset source file what it was that we used for import. And because we can always read this file itself in first, we probably are fine. And to that end, we may also be able to actually have this overwrite the current state of things, so we probably could even make it work now, although I'm not entirely sure. So let's see about that. If I look and we talk about, inside the asset importer, if you remember correctly, what happens in here is we do this. We have this notion of like a parse pieces call, right? And inside parse pieces, actually, I can use some of these new features we got here. Just jump right to it. Inside parse pieces, what we have is this checking where it says like, oh, is it a block? Is it a head? Is it a body? Is it a character? Right? So effectively, what we do is we store that type token in here, right? And we sort of remember. From that string, what is the layout that we should be using. And because of that, what kind of happens here is once this piece import occurs, we sort of lose the ability to, we don't have any way to recall what this actually is. Oh, although, I just had an interesting idea, though. So I just had an interesting idea, and I'm not sure how I feel about it. I don't think I like it, so I think I'm going to skip it. What I was going to say, let me just put it out there. What I was going to say is there is another way we could do this that wouldn't require the change that I'm about to make. Which is that if you always rewrote the file by first reading the file in and writing it out as you go, there's two really interesting things that would happen there. And, gosh, it's kind of tempting. Let me fully describe what I'm talking about, because I don't want it to just be happening in my head. I don't want the battle about which to do to only happen in my head. You know, I try to avoid that on Handmade here wherever possible so everyone can kind of hear my thought process. So here's what's going to happen in the abstract. And then let me tell you about why the thought I had was a little bit interesting to me, and I hadn't really considered this before. So let's suppose that what we did is the most straightforward way of augmenting the current system to do what it is that I wanted it to do, right? So the way that I thought of first, because it's the way you would normally do this, right? So let's say that's what I wanted. I wanted to just say, let's take this system and just, I want to be able to output that this thing is a block or whatever. I have the file name in here, right? And I know the assets themselves, so I can get, you know, the rest of the information out of it, like what their tags were and stuff like that. But if you look at what is happening there, I do have, well, actually, and now I think about it, there's actually more issues too that I might have. First, right, is I don't know which one of these it is, because I'm not storing that in here. So what I need to do is I need to add that information back. Second, I would need to write out which tags are common to this thing that are not in the template. So I'd have to actually do a diff of the art asset tags themselves and see which tags are on the assets that aren't in the template for that thing. Or store the extra tags here myself, right? So that's a little bit of extra work too that I hadn't included. So I'd need to do those two things, but then once I did those things, you could presumably all see how I would like rewrite out, say, block orphanage 01.png, right? It's pretty straightforward to see how we would do that. But the thing about that is, if you actually consider what's happening there, a lot of other information when I write this out will also get lost. Let's just talk about something very basic. This comment, right? Where's that comment going to come from? The comment's not stored anywhere. We have no idea why that comment was in there. Worse yet, what about this? Even worse, what about that, right? Those are things that maybe I wanted to re-enable later. And so the more I think about it, the more I'm thinking that my weird idea is maybe not so weird and it might actually be the right thing. So what if instead of doing it that way, what if we do it a completely different way? What if we instead make a system that just reads the files, that all of the tag files, as if it was going to do an import, but instead of importing, it just rewrites a new file for that tag file, and it just looks at whatever you've added and inserts that in there, right? So every time it reads one of these lines, it just copies the line into the text file unless it sees that you've modified what it says on that line, and then it puts it in there, right? It's a little more work, but then it kind of all allows the code to actually function properly, and all the things in there, like the comments, or the defaults, right? We wouldn't have any idea that there was a default block. We would just see that all of these assets had these names. We could sort of try to reproduce that, but we wouldn't even necessarily know where the default block got changed and when or why, right? And more importantly, we wouldn't necessarily know the difference between something that looked, you know, like author Anna Repberg here and then author something else for the rest of these, and one that just had author specified on this one and then a default for Anna Repberg up here or something, right? Because all we would see is what the author actually was on each of the assets. That's all we would know. So, I'm really leaning towards that. I think I'm just going to do it. I've never done anything like that before, but it really seems like the right solution, and I don't have an argument against it. The only thing I was going to say is that it makes it a little weird to do edits for things that don't exist in here at all. But I guess those are things we could just handle specially. So if you add a new thing to the system in its entirety using the UI, we have to store that separately. But I think that's okay. I don't mind just storing that separately, I don't think. So we'll see. So I think I'm actually going to do that, as strange as it sounds. Let's just do that. I mean, you know, go big or go home, right? I mean, that's the thing. I mean, this is We're professionals. We're professionals Twitch streamers here. We're Twitch partners. Okay, this is not some rinky-dink programming stream, right? This is the full deal. We have custom emoticons. We have custom emoticons on here. Does anyone even know that? We just set these up. I don't even know. Check this out. Does this work? I don't know if this works or not. I think it might work. But you know, I couldn't really tell you because I'm not 100% sure. But I think we have custom emoticons. Indulge me here for a second, people. Let's go into the emotes thing here and panel. Okay. Try doing an emote of HANDMA2, which is the thing they assigned us, handma2. Do handma2 capital G lowercase LOVE. Yeah, oh, someone's got them right there. Right there. Yeah. And then there's Handmade, there's Molly, there's Hero, and there's Glove. We've got. Are those coming through? Let me take a look. Let me see if we got that. Let's see here. Oh, yeah, check that out. Check that out. Look at that. You're crushing it. All right, so we've got all kinds of custom emotes here. There's even ones for like special subscribers. Like we went all out. Like everything is up there. I don't know what. Let's see where the ones for the special subscribers are. There's two other ones that we put up there. Handma2 Baby and Handma2 Krampus are also in there for special subscribers, which I'll be honest with you, I don't really know how that works. I said I was a pro streamer. I'm not a pro streamer. Let's admit that up front. I do the best I can, but I don't really understand Twitch super well. So, you know, all I'm saying is there's emojis in there, and I don't know how they work, but they're in there, and I think that counts for something. The fact that I don't really know how to use the UI that sets up the Twitch emotes, notwithstanding, Anna did draw them, and I did upload them. So, you know, so pro streamer. Right? And you know, it's not my fault. I don't have one of those weird chairs that like comes up to here for some reason. But we're still pro streamers. So, all right, let's just do it. I talked about this the other day, actually. So one of the questions was, what's the difference between like this tokenizer and maybe one that's a little more industrial strength? There are some things, certainly. But the biggest change that I usually make structurally, and I'm going to make that change right now, is that there's two stages to tokenization. Raw and unraw. And so I'll show you what that looks like because we're going to want it now to preserve our comments. And so I'll show you why. So in a tokenizer, typically what you do is you have this function called getToken or something similar to it. You've seen the way ours works. Ours is pretty basic, right? We're not trying to break any land speed records here. We're not trying to do anything too fancy. We just want basic tokenization, and that's what we're doing. But when we call this getToken, what you can see is there's some filtering that is occurring on the token. All right, and let's talk about what that filtering is. So first and most important, eat all white space, right? And what eat all white space is going to do up here, you can see, is it's going to skip right over those comments, right? Those comments are just gone, munch, you know, there they go. And so that's one big thing that we're losing when we call getToken is any comments that are in stream are gone. Now, normally, that's what you want when you're parsing because you don't want to think about token. You don't want to think about comments in your token stream. You don't want to check. I mean, and let me just, again, for those of you who don't work with parsers very often, it might be a little non-obvious how all this stuff works, and that's okay. This stuff is kind of complicated. Once you work with compilers a little bit, you get used to it, but at first it's a little bit strange, certainly. But, you know, take a look at how this code works, right? You can see in here, we do stuff like, I just saw the token default, so now I know that the next thing is going to be this open brace, right? Because it's a default, so this is backwards, by the way. Nice job, guys. No one caught that. So is default is going to say, look, I've got one of these. I don't need to look for the string because it's the default, not a normal one. So what I'm going to do instead is do require token open brace because I know that I get the default token and they get an open brace, right? And you can see that happening in here, right? Default open brace. So that's what we're looking for. But the problem is the user can stick any number of comments in here, right? And so what I would have to do in the parser, if I actually made a comment be its own token, right, is every time we got a token, like right here, every time we did token equals default or something like that, I would have to do a while loop while it's a comment, eat all the comments, right? You see what I'm saying? And so that's a problem because it makes all of this code more complicated and weird. But what we can do, like I said, is have the parser just handle those. And that's the way we wrote it. Every time you get a token, it returns the next actual meaningful token, and it throws away anything that's just incidental to the code stream, such as a return or the comment or whatever, right? But what if we want all that stuff back, right? What if we want all of that stuff back? Because I want to reproduce the input into the output. I want the comments, I want the new lines where they were, I want it laid out exactly as the user had intended. I don't want, right, to put this sort of other stuff, I don't want it to throw away all of what they did and only have the bare, the bare structure of it come out the other end. I want their comments preserved. So if we're going to do that, again, it's actually not that hard. This is something, I don't know if other people do this. This is just something I made up at some point, but I would suspect that other people probably do similarly because it's just, it's the design that you would do, right? Is you turn your get token into a get token raw. So instead of having get token be the thing that actually processes the token, you have a thing called get token raw, which is actually the thing that now processes your tokens. And then you introduce the get token call as something that operates on top of that. So everyone who was calling get token before can still call it. Oops, I put that one too low. Everyone who was calling get token still calls get token, but anyone who wants to reproduce the stream can call get token raw. And that way you can get those individual pieces back much more easily. Okay. And what get token raw does is it actually preserves all of that stuff, right? So all of the white space, all of the comments, all of that stuff can actually just be handled in here. And so now what we do is we take this routine for eat all white space, right? And we grab that and we kind of shove it into here, right? So we say, look, this is actually where we're going to be processing the white space, not what you were getting before, right? And so in here what we'll do is we'll say, all right, let's get this white space out and process that properly. So here is what we'll be looking for. Right, these are our white space characters that we know of, right? So these are the white space characters that we know of, and you know we also have these comment ones, right? So / and star and that sort of stuff. Those are things that we have to care about, right? So we've also got this. So here's our white space, and here is our slashes. And so let's go ahead and process the slashes first, okay? And if I want to, if I look up here, I notice we're not using slash for anything. Maybe I might do this a slightly different way because we happen to not use these for anything else. What I could do is actually move these into my default clause, and that would work as well, right? So I could put those in here as something more like this, right? And so the way that would look is like this. And so these become welded together. So what I'm doing now is saying, all right, let's take a look when we do our default thing. Like we were doing before, we're going to scan for things like identifiers in here. But we're also going to scan for the other things that we were scanning for, such as if there was a piece of white space here, right? If there was a comment, you know, C style, C++ style comment, if there was a C style comment, and then if it isn't any of those things, then we will continue processing it the way that we were processing before as you know, something else. So what we want to do here is if we see a white space character, then we will do a while loop to get all of the white space out, right? And we'll just consider that one big chunk of white space. If we don't, right? So if instead we see one of these comments, we'll get out the comment. The only thing we then have to do is, again, like you can look at what's happening in here, right? At the end of all of these, we're doing a token text count equals the input data minus the data, right? This sort of thing here. This is always going to be true for all of these cases. We're always going to suck up as much of the token as we could there, right? And so all I really have to do to support these comments as proper tokens is to just say, hey, every time you grab one of these, just now set it to comment, right? Off you go. And I could differentiate between these if I wanted to. I could say that this was a CPP comment, right? Or I could say that this was a C comment. I don't know that we're ever going to care which kind of comment was which. I think we just don't need to know. So for now, I'm not going to differentiate between those. I'm just going to say that there is such a thing as a token comment, right? Now let's go a little bit further. Let's keep pushing our advantage here to the extent that we have one, and say, all right, so in that case, let's say we've also got token whitespace, and let's say we've also got a token, let's say, new line, right? And this way we can sort of do some processing of a few other things as well. So if I wanted to do that, now we know that we've got token comment in both of these cases. That should just work because we already have the code for sucking up whatever inside the comment. Let's also process these other things. So let's stop thinking about is whitespace. Maybe that's the wrong thing to think about. And let's do something a little bit different, which is let's think about whitespace. Let's think about is whitespace a little bit more broadly. Interesting enough, it looks like we have two is whitespaces. Why is that? So we have is whitespace with a B32X and is whitespace, oops, as a inline. Why is it coming here? That's weird. It's like some kind of weird bug. Well, I'm not sure what's going on there. Wonder if that parser's busted or something. This is sort of not the full version of, it's not even the, it's quite old of the new 4-coder stuff that I was doing in here. So I wonder if there's some kind of, I'm not sure what's going on there where it's listing two of these, but one of them it doesn't seem to know where it actually is. Like there it is. But this one it doesn't seem to know. And I wonder if there's some kind of a weird bug in there. There's only one is whitespace routine here, but I'm just not sure where it's getting that one from. So who knows? Anyway, I won't belabor the point for now. So in here, what I'd like to do is take a look at these and say, oh, and you know what? Actually, looking at this, it looks like the is whitespace here doesn't actually have end of line included. So actually, this would have not really worked properly. I wonder how that was working before. If it's because I think it must have been. Oh no, it does. It does. It has is end of line there. So I think what we want to do is something like is spacing, right? And then we can basically duplicate this out into here, so we can check for these things individually. And so this will just call is spacing or is end of line, but then you can call is spacing as something that's a little bit more specific, so you know the difference between those two. So I'm going to do an is spacing here, and this will eat up all spacing characters, and we'll call that token spacing versus token new line, right? So if we have token is spacing, we'll suck all of those up into one thing that's a spacing token. And then if you have a new line, is end of line. Then what we want to do is remember that that's the case. And it looks like I should call that end of line. So when we get that, there's an important thing to remember here, which is that end-of-line processing is kind of delicate, right? And so when we actually suck up this token, we want to do this in kind of in a bit of a meticulous way. If you look at end of line here, you can see we're checking for either of these two things, but there's a number of ways that line endings can occur. Let me show you what I mean by that. There's Linux, there's Mac, and there's Windows. I was hoping this would be, here we go. So you can see on here a little table of how line endings have gone, right? And what you can see is that there's a lot of nasty variance between what these were. Now, let me give you a little bit of background on how it got this way, because you're probably looking at this, especially if you're fairly young and never lived through the terminal years. You probably are wondering why it could get messed up this badly. Although, you know, if you've ever seen CSS, you're probably not wondering that. But you're probably like, wow, this is relatively clean. So if you think about how these escape sequences are working, these are special ASCII codes, right? A \n actually translates to OXA as a hex value, right? And \r is OXOD, right? Or just OXD as a hex code, right? And so those are non-printing characters, and they represent when you're trying to go to the next line. And if you look at what happens here, \r and \n, you might be like, well, why is there some that are just \n? Why are there some that are \r, \n? Why are there some that are just \r? Why are there some that are \n, \r? Like, how did that happen? And the answer is because these date all the way back to the years when you actually weren't talking about like raster displays on a microcomputer or something like that, right? You were actually talking about things like, I have a mainframe and it's connected via some kind of cabling or even over a phone wire to like a VT100 terminal or something that's just a dumb terminal that all it is a screen and a keyboard and a little chip that's only smart enough, a little chip, there's still a big board those days, that's only smart enough to like send things off the wire when they're pressed and receive things back from the wire when they are received. And all it had from memory was just the buffer of what was on the screen. That's all it remembered, right? So what these things corresponded to were actually two different operations sometimes. One is go back to the beginning of the line. And I believe that's \r, right? So in the old days, if the terminal got OXOD, what it meant was wherever you were on the line, because remember, it's keeping track as letters are coming down the pipe, it's stacking them one right after each other across the screen, right? Then if you do \r, right, which was OXOD, right? If you got an OXD down the pipe, what it meant was wherever the cursor is, go all the way back to the beginning of the line. Don't go down, just go back to the beginning of the line, right? \n, on the other hand, or OXA, if that came down the pipe, it meant move down one line, right? But it didn't necessarily mean go back to the beginning of the line. And so the protocol for these terminals and the protocol for these transmit formats and however else you want to look at it, because there was no real standard, it was fairly flexible. Some people decided, well, you know what? Generally, when we go back, we want to go down a line and back to the beginning. So let's just send OXA, and that'll mean like go down and back, right? Other people were like, no, let's have two codes, one that is the thing that go back to the beginning of the line and one that is to go down a line, right? Let's do that. Other people were like, well, you know what? I agree we should only send one, but instead of sending OXA, let's just send OXD. That's the thing that needs to go back to the beginning of the line. That's the one we would probably want to automatically go down, not the one that goes down. That one we might want to use just to like stay where we are or whatever, right? Et cetera, et cetera, et cetera, et cetera. So it's just historical accident that we ended up with this. Nowadays, you would never do this. You'd just have one way of encoding end of line, but that is not the way organic systems evolve, right? So what that means for us is if we want to generally not care what kind of text editor produced this thing, because we don't know what, this text editor could have done anything. Who knows what it's stuck in at the end of the line? Maybe it's doing Mac format or Unix format or Windows format or who knows what, or any of these other things. Who do we have up here? Like Linux, Mac OS, FreeBSD, AX, Xenix, BIOS, Amiga, and RISC OS, for example. Or maybe it's Atari, Windows, DOS, Tops 10, right? Or maybe it's the Commodore. Maybe it's the C64. I don't know, right? So who knows where this came from? Or Mac OS. Maybe someone's using an old Mac, one of those ones that has a little smiley face when you boot. All right, so if we're doing that, then what we want to do is when we get an end of line, we want to look to see if it matches any of these possible sequences. And if it does, we want to generally assume that the largest sequence we could match is the end of line. So that if it inserted this or this, we will suck that up as a single end of line character instead of treating it as two end of lines, which would be incorrect, right? So what I want to do is say, all right, this is an end of line token, and then I want to look and see if tokenizer at 0 equals something, and tokenizer at 1 equals something, then we'll consider advancing. Right? And this cover is, in fact, I could do it this way as well. So what I could do is do 2 of these checks like that, right? And so all I want to do here is say, look, when I get an end-of-line character, if it's just a \r by itself or just a \n by itself, we'll assume that that is what the text editor is using for an end-of-line. But if we see a \r followed by a \n, or we see a \n followed by a \r, we can assume that we need to move one more character forward, right? Because we've sucked up one of the characters, but we haven't sucked up the other character, right? So we want to skip that so that we don't treat it as 2 end-of-lines. This will handle all 4 variants of the end of line that we could see no matter which crazy type of text editing line ending we got, it should still work. Because this way, if it's \r, \n, or \n, \r, we'll eat them both. If it's just a bare \r or a bare \n, we will just consider one of them. If it's 2 \n's or 2 \r's, that obviously means there actually are 2 end of lines, because there are no end of line formats that have 2 \n's meaning 1 carriage return. That's not a valid line ending that any text editor ever used. So we don't have to worry about that one, right? So now we have all of the ways we can get white space and comments and stuff into the system, and now we can call getTokenRaw, and getTokenRaw will then give us what we actually needed to use, right? Okay, so now we can sort of imagine what you would do if you did want getToken. We probably won't really use getToken very much because we're going to have to sort of do a little bit of a porting style shim here. Probably, I mean, it depends on how we want to do it. You'll see there's probably some fancy pants stuff we can do here. So maybe we will actually call getToken. We'll see how we want to make it work in the end. But so you can now see how getToken would be implemented so that you can get either one. What you're going to do here is you're going to say, hey, let's get the actual token from getTokenRaw. And we'll see what it is. Right? And I probably want this to happen up top. Right? And so what I'll do is I'll go into my loop. I'll getTokenRaw. And I just won't exit the loop when it's a token that I don't care about, right? So if I want to, right, I can just do an if, token.type equals blah, else break. And in the equals blah clause, I can just put the types that I actually care about, right? These ones here, I'm sorry, that I actually don't care about. I can just do those. So if it's a spacing, if it's a spacing, if it's an end of line, or if it's comment, I'm just going to ignore it, right? So that'll allow me to kind of eat forward through the stream. And then the other thing I want to do here, we'll talk about in 1 second. But what that means is when I call getToken now, I'm only going to get things that were actually valid to the code stream and that actually have meaning. Anything that was just white space, end of lines, or comments will still get filtered out. So now it has not changed the behavior of the parser at all. The parser still works exactly as it used to. But we now have the ability at any time to really talk about the token stream at a lower level if we want to, which is exactly what we want to do for doing this sort of throughput processing, the sort of, what's the word I'm looking for? Unmolested copying, basically. We don't want to change in any way the input into the output if no changes have occurred. And we want to preserve all of that sort of connective tissue that was in there originally. Okay, so there's one other thing I want to do here, because since we ended up doing a slightly more hardcore parser, I also want to talk about one other thing, which is there is a string kind of type, right? There is token string. And what I want to talk about here is just that if you look at what happens with token string, so in here you can see we get this, right? You can see what happens here. We go in and we say, look, if we had a quote, then what we're going to do is we're going to actually skip that initial quote char, right? That initial quote char is going to get skipped. And you can see us right here not actually touching that end quote either. So we're leaving the actual value of the token, okay, is what's inside the double quotes. And that means that it's modifying the input in a sense, right? We can't just copy the token value to the output and expect it to work, right? We don't want that to happen. We want this to be preserved. And so if we do that, what we can do is recognize the fact that actually, let's leave that in there, right? Let's just leave that in there. Don't update this, right? Don't update that at all. And don't do this, right? Let it actually advance over that. This has two really interesting benefits. The first is the fact that here, well, I guess there is one thing that has to slightly get a little bit more complicated. Well, actually, no, it doesn't have to do that now that I think about it. So actually, this is kind of cool. So let me show you what happens here if we do this. If everybody always uses the actual input that they're given as their token value, and that gets modified later, as we'll talk about in a second, then what you can see here is this part of the process actually gets simpler. Instead of everybody having to think about how they're going to set it, now literally nobody does. So this is always the code. Oops. This right here is now always the code, every time. So no matter what happens, when we come in through here, right, no matter what happens, we always set the size of the text to just be wherever we ended up, right? So however far we advanced from the time that we started, right, which is here, we always end up setting our count to be that much. Nice and uniform, really kind of cool, right? And then what we do is in here, when we actually get the tokens and we go to say, let's produce sort of the processed version of the token, this is the point at which we can do something about it. So in here, when we get this string, what I can say is, let's trim the quotes off of the string. So pretty simple, right? All I have to do is say, look, if the token, and let me just flip back here. So if the token text has anything in it, right? So if token text count is great, well, it's just this, right? You know, if it's not 0, right? If there's something in the token and the very first thing in it happens to be a quote char, skip it, right? Make sense? That trims the leading quote. Here is the trailing quote. Same thing. If token text count still has something in it, then if the last character is a quote, skip it. And so what this allows us to do is this allows us to make a really simple tokenizer two-stage process that means that now there's no special handling. Everybody just goes through, sees what's in their particular chunk that they want to figure out how big it is. However much they ingested is how big the token is always. And then there's a second stage that just goes through and says, look, I'm going to go through this and I'm going to go ahead and, in fact, I can do this a little bit differently. We will always break here, but we can make that like that. In the second stage, I will eat any token that's just white space because I don't want that, right? And then when I get an actual token, I'll return it. And by the way, if I look and see that this thing is a token that needs some kind of further processing, I will process it, right? And off you go. So that's this really nice two-stage design for a tokenizer. It pays some extra dividends too. I'll show you those right here. Let's suppose that we wanted to start doing error line number tracking. So you can see that we kind of set ourselves up for this. We have this notion of a line number in there. We have this notion of tokenize. Inside here, we sort of say, hey, yeah, let's set that line number to 1 because we're on the first line. Let's set that file name to something because we need to actually know what the file name is actually going to be. And I might say, I don't know about the file name, but probably let's make the file name a string. Probably, right? I think we want that to be the case, so we'd say something like this. So this is the file name that we're parsing in terms of, for error reporting. So when we tokenize the input, we would do it this way. And I don't know exactly how we want to do that per se, if we want to initialize that or if to force people to do it. But it looks something like this. So in here we'd say, all right, there's the file name that we're parsing. We're starting on line number 1. Now if we want to report those errors, it becomes really good. We can actually be super hardcore here and even say column number, right? So if we really want to be Mr. Fancy Pants, this is a parser that people are actually now using in the real world and in life, and it produces good error messages or something like that, we can even have column number. Why? Well, take a look at what happens. Inside here, we say advanced chars. Every time we do advanced chars count, well, guess what? That's the line number count. Not particularly confusing. Also, as far as I know, does advanced chars ever do anything other than advanced chars 1? There's a 2 here. So it does occasionally do 2. Well, that's fine. All right, so anyway, in advanced chars, we know that we're always advanced by a certain count. That means that the tokenizer column number, right, that we've got here is always going to be advanced by that much. So it's pretty easy to find out what the column number is. And furthermore, every time we generate a token, we know that the line number is always the tokenizer line number. Oh, it's actually already done that. And the column number is just the tokenizer column number, right? So we know the column number always advances here. All we need to do now is know what the line number is. Guess what? We're parsing end of lines now. That makes it really, really, really simple to do that, because now all we do is every time we see a new line, we reset the line number. We advance the line number and we reset the column number. Right? Now, all of a sudden, we can actually do really robust error messages where we actually say exactly where the error message came from, which is pretty baller. And so on here, for example, where we do this outf and we've got all this nonsense happening in here. By the way, I'm not sure why that's being passed to outf. So why is outf getting the file name and line number? Does anybody know why that's happening? I think this is not correct. I mean, it should be error F if it's getting those things, is the thing. That seems bad. Because why would you be... Well, you know what? I don't know. I'm not going to criticize myself. We'll just leave it the way it is for now. That's fine. But it's stupid. And so what I'd like to do is figure out why we were doing that, and do we actually use that, and if we do actually use that, how. So let me take a look at where that's actually happening. So if I list locations for outf, I want to see like who's doing that and why. So in here we got our error messages. Those are fine. If you look at like on here, for example, so that's doing an error message, but it's actually got the source grid. Like that's not what we actually want there. So I'm just looking at this. So I don't really know. It looks to me like outf shouldn't really have that. Probably. I mean, you could. There's ways in which I could see that being the case, but I'm really torn. Okay, so let's say this. Let's do this. Because these chunks say the file and line number here, we have to imagine what would you be doing with that file and line number, right? And do we want that file and line number to correspond to like the text file input in the case where you're processing a text file input? Or do we want that to correspond to the piece of code that's issuing the error message, right? And I don't really know the answer to that question. I'm not sure. And that's why it's just a little bit squinky in this case, right? I think what I'm going to say is that should just, the outf should be like a separate thing, right? The outf should be doing, it should be talking about code errors so that you can jump to the piece of the code that issued the error in case you wanted to do that or something. I'm going to say that that's more what it is, maybe. I don't know, sort of, kind of. Don't quote me on this. I'm really torn here. As opposed to storing what the actual file was that got loaded and that was generating the error. I'm just thinking that's probably what you want, but I really don't know. Let's say that that was the case, and we can always change it later if it turns out that it's stupid, right? So I'm not going to do this because that is not what I want to do. What I'm going to do instead is I'm going to call outf in both cases, right? Like so, and I'm going to actually put the error information into here, right? So I'm going to say here that this is the error in question, and then here comes the rest of the information. Oh, and also we should print out what that token was in the case where there is a token as a separate issue, right? Okay, so in here what I want to do is say, well, there's some token in here that's the token that we want to record as being the error as well, and I'll quote that so you can see what it was. And then there's the error message that you actually have, and that'll go in there. I don't know to what extent this does carriage returns or anything like that, so we'll have to kind of talk about that a little bit later. And I guess that's because it's streaming. I guess this would probably need that as well. I want to say. I'm not 100% sure about that, but we'll just say that that's true. So this would be how we would have to make that formatting work, right, in order for everything to work okay. And so in here we would pass the on token file name, the on token line number, and the on token column number, right? So that would give us those three pieces of information. So we would just be able to print those out as necessary. And then finally, for the actual content of the token, we would just pass in its text field. So that gives us error reporting pretty cleanly. In here, where we don't actually have a specific token, we still could print out a token if we wanted to. And I'll show you how that is the case. So let's suppose instead here we were to want to print out something similar to this. So we want to print out something that looks like that. But now we don't have the on token. That's okay because we could make our own on token, right? That if we wanted to. We could pretty easily do that. And the way that we would do that is we'd say, well, look, we know that the tokenizer can still get us a token, right? So what we could do is just actually like peek the token, like get whatever the next token would have been if we wanted to do that, and use that. So for example, if we wanted to, in here in a Handmade tokenizer, you can kind of see how we've got everything stored here. If we wanted to, we can pretty trivially do a thing where we get the next token without actually pulling it off of the input stream. And there's a lot of ways we can do that. The easiest way by far to do it, if we want to have a peek token call or a peek token raw, either way, it's really pretty straightforward. All you would do is say, look, I want to do peek token raw. Hey, save the state. Restore the state. Right? Pretty straightforward. So all you have to do there is say, hey, let's get that token. Now, there's a reason why you might not want to do this. And it's worth noting, we don't have the problem currently, but it's really worth knowing that this could be bad. So if you were actually to call peek token raw like this, and I'll support this call because I might as well, but I don't know that I'm actually going to use it, and I'll say why in a second. So if we wanted to, we could call peek token raw. So I could just say, look, give me whatever the next token is off of this tokenizer, and then I'll display that as the on token. There are some reasons why you probably don't want to do that. And the reason why you probably don't want to do it is just because, look, if you do that, you're definitely in danger of re-entering your own code. So let's say that we have something in here that generates an error message. The peek token call could generate an error message, which then causes this code to loop infinitely as it keeps calling peek token and keeps getting an error message, right? So there's something to be said for not really doing peek token that way, but for our particular purposes, it's really not a big deal. So I'm just going to say, screw it. It's fine, right? So off we go, and it's just worth noting that there's other ways you might want to do that. It depends on what you're doing, obviously, but off you go. So this also means that we probably just want to make one of these, just to make it a little bit clearer what's going on here. We probably want to do one of these where we just pass the arg list, right? So something like this. And then this is really just the same call in all cases. Oops. So there's the actual call that we're talking about. And then in these cases, it's just a question of how do you actually fulfill the parameters in question. Do you get them from the caller, like in this case, or do you generate one of them yourselves, like in this case? But this way, we're now being more uniform about the way it's being called. And so that way, if we modify the way that this works in the future, both of our errors will automatically inherit the changes without having to be sort of kept in sync or anything like that. So that's just a little bit more pleasant in that regard. All right, so if we look at what happens here, we can see that we've got just one slight error where we didn't copy the change that we made in the CPP file up to the H file. Gotta love that C nonsense there. So anyway, just put it in here. You can see it's the same thing. It just takes the file name now. So everywhere that we were tokenizing, we can now pass an optional file name. And so we should go ahead and do that pretty much everywhere because we'd like the error reporting to be good there. Oops. What did I do? What did I do? There we go. Forgot semicolon. So here where we've got like file buffer, what we need to do is get the actual file name in there. And so if we take a look back at our platform layer, I believe we've got the, what is that called? Platform file info. So inside platform file info, you can see here we've got this base name pointer here. So I believe that's all we need to pass for like what the name of the file is. So it doesn't include a path or extension. It's kind of a little bit weird that we're doing that at the moment, but I guess that was just our convention because we were kind of using that as a thing before. Probably want to put the extension back in there, honestly. It's not great. But anyway, at the moment anyway, you know, that's fine. So that's going to be wrap base name off of that file info. And then presumably there was some other places that were tokenizing as well. Was that the only tokenizer? Maybe that's the only one. All right, that's the only one. So now we'll get those error messages will actually tell us exactly where we're getting the error, and that's a lot better, right? Because that way, if we look at, you know, problems that we get when we're done with the export, that'll allow us to know what the heck happened, right? Which is kind of something that we want to be able to do. All right, so now let's move forward from there. And we also kind of need some ways of maybe printing those out and showing those a little bit more clearly. Right now, we can look at them on any given asset if it had an error. When it was imported, we can see that, but that's really the only way. We can't say after we do an import, show me all the errors. I don't think that's currently something that works. And so we kind of want that to be the case. So like in here, you know, we would like to be able to, at the end of things, say, show me all the errors that happened during this import. So that's probably something we want to put in here as well into some kind of buffer that we could just view the errors. So that's just another thing that would be nice to be able to do. Something to think about. So that's pretty much it. Now what we need to do is talk about how we're going to actually do that, you know, writing process alongside our reading process. So when we call parse HHT here and we're reading through it, right, this is the function that would actually need to do that sort of, you know, copy. And what you can see is as this is plying through here, parse top level block is going to want to do its own copying as necessary. But any other token that we're getting here, we want to kind of copy it to the output, right? So what we'd rather do is say anytime we get a top level token, we want to be able to put sort of incidentals and move them from the input to the output, and we don't really want to fuss with them at all. And so we should probably not quite do that piece of code yet. And the reason I say is because it's just not very complicated. Like all it would be is a get token raw, check to see which type it was. If it's one of these, we process. If it's one of the things that we want to just copy, like comment or white space, we do so, and then we process the rest the exact same way. We may not want to quite do the input to output copy exactly that way, and because of that, that's why I was saying I kind of want to look up at something more complicated first to see how we might want to do that. So if we come through here and we look at parse top level block, and pretty much that does like all of the parsing, right? This pretty much does everything. If you look at how this is grabbing the you know, it's just kind of lemon grabbing off of the data there, just pulling things off one at a time. We probably, just looking at it, right, we probably want to do a thing that just says, look, at certain points in the input stream, just copy everything that you saw because it's all fine, right? And so we just want to put a thing in here that says, yeah, just get all of that stuff that you've got, like get all of that stuff you've seen so far. It's all fine, so copy it, right? That's probably more like what we want to do. And so I don't think we really want to do something where we're doing a token by token copy that way. And so what I'd rather do here is say, all right, look, when we actually get down into here, by the time we've gotten to this, I guess I want to say something like, I think I just want to say like, okay, if you got the open brace, just like this, you know what I'm saying? Like take everything up to, and maybe, you know, I don't even need that. I could just be like this. And so I could just say, up, you know, up to and including maybe. So like do this whole thing, right? So this would just basically say, look, everything, just copy everything up to the open brace so far is all good. We haven't had to make any changes to it. So just copy all that, right? And then we can look at the parsing here and say, okay, we're going to get all of this stuff out, right? And we're going to have, there's going to be like a new set of stuff that we need to sort of output here. And we should try to figure out whether that stuff needs to come in probably like line by line, right? And so the way I want to do that is say, all right, there's one thing that we haven't put in here that we need to put in here, and that's these markup points. So let's try to put those in so that we have the full picture. Pretty sure that's the only thing that we edit, right? Is alignment points? I mean, we got tags, so we can diff those potentially, but. So here you go with HHA align point type, right? And HHA align point. If I look at a bitmap, that's all there is. Like dim and origdim are processing based things, so it's really just these two. I'm sorry, just this array. And so if that's all we're doing, then all we have to do is output these, right? Each of those just has to kind of be specified, and the size and the p%, probably we want to just represent them as their 16-bit versions. We could represent them as F32. I don't know. I think I kind of just lean towards just keeping them as whole numbers, because I don't see us ever editing these in text really, because we're always going to use the editor. So we just replicate the 16-bit value out. Seems fine. Maybe, possibly, probably. I'm not sure. We can think about that later, but for now, I think I'm going to say that's how that goes. Yeah, probably should. So what I want to do is say, look, if the token is a line, then that's going to be an align point statement. And the align point statements will probably just go like 0 through whatever. And I don't know how we want to specify that, but we could just say like this particular line point, like align point 0 is this. Now, an open question is, do we care about preserving the actual indices themselves? Meaning, is there any reason to say like align point 0 stays align point 0 and align point 3 is align point 3? Or should we just condense them down as we remove things? I'm going to say let's just leave them sparse, because I don't know how we might want to do that in the future. You know, I don't know what we want to do there. So I'm going to go ahead and say that like align can actually have like a bracket syntax or something maybe on it that allows us to specify like which one it is, right? And you know, again, don't know. Maybe we should just use a parentheses, but we were using parentheses sort of for values, so I might say let's not do that, and let's actually say that we'll do it this way. So we'll say that there's going to be an open bracket, and a close bracket, and then we'll actually get you know, an index out of it. So we'll also require a number to come out of there, right? So we'll get all those. We'll require an equal sign, because you're going to have to assign this particular align point to something, right? And then we will look at how we want this to be structured. And again, I think we just want this to be 100% rigid. I don't think there should be any way to really modify it. So it's going to be these three things. P% size, and then there's going to be the like name of the thing and whether it goes to the parent or not, right? Don't really know what I want the syntax of that to be. Let's think about it. So inside the HHT file, it would look something like this. So we'd say align point 0 is supposed to have a p%. So, you know, a p%, a size, you know what I mean? If we really wanted it to look like C, it would be the p% would look like this, the size would look like that, and then the type would be here. So, you know, like that, right? And if it was HH aligned to parent, it would look like that. And in here, for the p%, we would specify, I don't know, the two values, right? So that would be sort of the way that it would look if it were maximally expanded to look exactly like it would in C++, right? Now, the braces are not necessary, right? So we could just do this, certainly if we wanted to. And the HHA align is also not necessary because we know that that's the only thing that can be read. And the only reason we have to do that sort of stuff in C++ is because C++, you know, is designed by tree frogs, and they just let as many tree frogs jump all over a keyboard as possible, and then they call that the new specification. So, you know, in a real language, you wouldn't have to use the prefix because it would know that inside an assignment expression, it was the thing that you were assigning it to, and off you would go. To be fair, they tried to do some of that with namespaces, but of course they screwed it up. Anyway, let's go ahead and look at how this looks. You know, we could do something like that, and then it's pretty close to C, so it looks basically the same as it would look if you were writing it in C, but it's a little less verbose, doesn't have as many, you know, sort of arbitrary constructs in it that are, you know, sitting around. So if we were going to do this, what we would say is, okay, there's a tokenizer requirement that we get a number, a comma, a number, a comma, a number, a comma, and then after that, we are going to get an identifier. Now, after the identifier, we don't necessarily know if we're going to get a semicolon or not, right? We don't know what the next thing is going to be. So what we need to do is we need to test to see whether or not that would be the case before going any further. And here's where this sort of thing becomes a little bit more squinky there, because it means that we would have to use a peak token here in order to see whether or not the next thing was a semicolon. Because if it was, then we would need to not parse it and let the code down here below parse it, right? And to be honest, I don't know how the tags list is actually doing that. So if you go up to the tag list and you look at how the tag list is parsing itself, right? It looks like I see how that works. So, well, no, I don't. So it's not really working properly in here, right? This really does need to be a peak token, right? Because if it wasn't a peak token, then it wouldn't leave the tokenizer in a state that would actually work. So I'm pretty sure that this actually should probably, you know, have been written that way in the first place. So I might go ahead and say, all right, let's say we're going to use peak token. So here I'll peak token, and I'll just say, all right, you know, if the token that's coming next, and you know what, here's another question. How did optional token work? So optional token's totally busted, right? Because it actually always grabs the token. Is anyone calling that? Yeah, so this is, we kind of broke this, right? Because it's, yeah. So that's good, actually, that we did that. So we want to do a peak token, and then what we want to do is say, look, only get the thing if it was the right type, right? Oops. Now this is a little inefficient here because as you can kind of see, we're doing the same work twice, which is kind of dumb. And if we really cared about the speed of the parser, we wouldn't want to do that. But we don't really have to care in this case, which is kind of nice because we're processing so little text that it will never see it. So that's kind of nice. We don't have to be too worried about the way that code's working. So then, yeah, we can just do, hey, look, if optional token, I guess, what do you want to call that? Or, I guess. Then we want to require the other identifier. And that's it. Because you can only have one other one, right? So we're just going to grab that. We'll just lemon grab that out, and then we're good to go. And then we can change this code up here to do the same. So this can do a peak token. And that way it'll leave the semicolon in the input stream. If it actually gets the identifier here, then it'll just say like, oh, okay, actually retire it. And off you go. Now, there's some pretty easy ways that you can not do this work twice, and we should feel pretty stupid for not doing them, but we are just going to not do them. You know, I'm not going to do it. It's dumb to waste the time on that. So anyway, here in peak token, we've got sort of a, what's the problem? Did I not? Oh, you know what? I only put peak token raw in there. For some reason. There we go. Don't ask me what I was doing with that. Because we wanted both of those. We wanted peak token and peak token raw. I only put peak token in. And I never put peak token... And I called it peak token raw. I don't know, yeah. Out to lunch, I guess. Anyway, so I think that's all good. Let's go ahead and jump down here. So that we have to implement. Require token. Let's see. This should be tokenizer. That was just an autocomplete bug there. And then optional token or is undefined. So we're pretty much good to go. We just have to add that or. We don't have that operator. And so we just have to add that in. Again, it's super simple. It's just a one line in our switch statement here. So it's really easy for us to add operators if we want them, right? It's trivial. So I think that's everything. And let's see, last but not least, this here is supposed to be required token number S32. So that'll get us that number out as well. This also is something we can lemon grab. We want that to be a P%. And a size. This token identifier is, like, we're going to have up to 2 potential things to combine for the type. So this is like type 0. And I think that's everything. That should parse the entire align point thing out. And now we know what it is, right? And so really all we have to do now is say, well, okay. So as we're doing our import on this thing, and we're reading in the file, we just have to kind of decide, like, what are we going to do with the information that we've received. So there's 2 things that we can do with the information that we get when we process an art asset. One is we can go update the version of the art asset that we have, and update it with the information that we now have in it, right? The other thing that we can do is we can take the information that we have and write it back out to the text stream. Now, in these cases, we sort of have probably differing ways in which we're going to do this. We can make this more flexible if we want to, but the most like rigid and single path version of this is anytime we do it, since we know that align points are things that come from the HHA and get edited in the HHA, the align points would get updated from there probably. I don't know. The other way we could do it is look at which one was modified later. So I suppose that's also one way to do it. And I'm not sure, again, which one of those two we want to do. It's pretty tough to say because, again, in both cases, we're not really sure. So what I would recommend that we do here is we actually have in our context something that says which of this is going to be, right? So when we actually do an update, we can basically say, look, are we trying to write out a new HHT, so we should be like copying forward the information that we've edited? Or is what we're actually trying to do just do the import, so the HHT should actually like overwrite what's going on in the HHA, right? And so what I want to do there is just say, okay, which one of these two things are we doing? So, is this a HHT rewrite or not? And so we'll just say, if true, we are writing a new HHT from the existing one, not importing its values, right? And you can imagine getting arbitrarily complicated with this sort of stuff, but, it's... In order to keep things simple, I'm just going to say we'll just have two buttons on the UI. There's import, in which case it's just reading everything in, and then there's like save, and that's going to write stuff out. And we're not gonna conflate those two, right? We're going to do those two things as sort of. We're going to do those two things in ways that the user is manually saying which one they're doing. We're not going to try and guess based on looking at what the like file modification times are or something, who's trying to overwrite who. Because that seems dicey to me, and I don't think I want to go down that route. I think it's going to be too hard to always do it the right way, and I'd rather just have it be exact. So in each of these fields, right, when we're doing these parses, what you can see happening here is, right, we grab the author, the description, the name, the HHA, the tags, the align, and so on. And what I'd like to do is after each one of those, I'd like to see which one of these two things we're doing. In the case for the rewrite, if we actually do want to rewrite it and so on. Here's a required semicolon. Oh, that's after the while loop. Okay, so I guess I misspoke there. These things actually do suck up the semicolon themselves. So that was less good. I guess I was wrong. You don't actually need to do a peak token here. We actually wrote this to work this way. I guess that's fine. I guess there's no reason not to do that. The less peak tokens, I guess the simpler things are. So I suppose that's fine. And if we want to do that, we can just say, well, this here is just a... This is just a get token. And we can see if if we want to get semicolon. You can see why that's kind of ugly, right? It's just not great. And everyone's doing required semicolon. So, we made the peak token. We might as well use it and make the code simpler. It just seems better to me, right? So, let's leave that as a peak token. We won't actually suck up the semicolon. We'll leave the semicolon in place. And then we'll just delete all these and make our lives easier, right? Forget it. Right? And that way nobody has to look for that. You only parse the parts that are actually relevant to you, and then you can let the semicolon be handled by the end of the clause, and everyone's happy. Right? All right. So if in here we do, one of these alignment point parses or any of these things where we get the author parse or whatever. So when we do these, what we kind of want to do is we want to say whether or not this thing is going to get copied to the output or not in some kind of clean way, probably, right? So when we read an author, a description, or a name field, those are just not things that we edit in the game. So I feel like all of these can just sort of have a by default pass-through level where we just say like at any time that is just something that's going to get passed through. So when we do like the require token at the end, then we'll just do the copy all input, right? But when we have something like this alignment point, that's the part where we may want to override it. So in one of these things, what we'll say is, look, which one of these are we actually doing? Let's remember where things started, and we'll do a sort of a backup to there as necessary, right? Where we can say, we don't actually want you to copy this alignment thing in. We want to ignore it and skip basically the stuff that was coming. So we'll do an if here, and we'll basically, well, I guess we'll just do all this, and then we'll do the if, right? So we suck up all of that input, and then we'll say if the context says we're doing an HHT rewrite, then what we actually want to do is we want to write back to the output our own version of what this thing should actually look like. So rather than using what we got as the input here, we're instead going to discard it. And then in the other case where we do actually want to use it, that's where we're going to stuff it back into the alignment point for the assets in question. All right. Now, this is going to get a little more complicated, and I'm not sure how we actually want to do it, because if you actually look at what goes on in here, these alignment points can be more specific. So inside, like Handmade, base game by HH2, for example, this would work just fine for something like a block where we aren't really talking about alignment points for more than just the whole thing. In fact, blocks don't really have alignment points, so it's not really relevant. But let's take something simple like this plate in the intro cutscene. If we wanted to set an alignment for this plate, it's pretty easy because we can just use exactly the line we specified. Because in that particular case where we've got something like this, if we want to specify an alignment point, we can just say, well, there's the alignment point, and we're done. And we don't really have to look at it any more closely. But the problem that we're going to have is alignment points actually are much more complicated than that, because a single import directive can actually import a lot more than one alignment point set, right? The reason for that is if you look at what happens in like the base game, for example, one of these things, like, the body hero, for example, that's got, in addition to possibly wanting multiple of these, which we supported with this array statement, there's actually also the grid, right? So not only do you have to specify which one of the alignment points you're talking about, you also have to specify which grid location, right? So it's really more expanded than even that. So inside our bracket syntax, I think we're going to need something harder core here, which really is this, right? So there's grid X, grid Y, and then the index of the alignment point. And that's really the more fully expanded version of this thing that we need to support. And like I said, it's a little complicated if you were entering these by hand. The whole reason we have an editor in the game is so that we don't edit them by hand. So I don't know that we care that it's, fairly squinky, because we're never going to touch it. So as long as it's legible and we can go inspect it and be like, okay, I see what that means, we don't really have to care one way or the other, right? All right. So if we come back here to the alignment side of things, we grab all this information, and then what we're going to do here is say, well, inside here, we're going to talk about that a little bit more specifically. I'm going to say in here that we've got token type 1, and I'm going to go ahead and have that fall through properly. So that way we do the full parse, and then we can look at the rewrite here. If we're going to do the rewrite, then this is where we'd actually output all of our stuff. And what we can also probably say is we probably don't actually need to do it here. We could just instead do it a little further out. So, we'd actually be doing it more like out here. You know what I'm saying? That sort of thing. So like when we get to the end of this thing, in fact, we could even do it. Where do we get the final semicolon? Or the close brace, right? So in here we could say, look, if we're going to rewrite it, now's the time to output the alignment points and do it that way. Otherwise, let's just preserve everything that was written in here as it was written in here. And there's other ways we could do that if we want to, but I think that's the way that we would want to do it. So in here we would do it, or if we're going to rewrite it, we do it there. If we're not going to rewrite it, here's where we would set it, right? And that's how we do it. Now, we can be fancier. Excuse me. If we want to reproduce the input exactly in all cases, we could be fancier. What we could do is rewrite only the ones that we saw when we saw them, and then remember which ones we rewrote, and go through and see if there are any ones that are specified that we didn't rewrite. And we would do that by keeping a flags array, right? We would do that by keeping a thing that said, look, let's set each of these things based on whether or not we've seen it. We will, process the output either at the time we saw it so that we keep the order the same, or we won't. Now, again, at some point you get into a case of diminishing returns there. Do you care or do you not about reproducing the input exactly? And you get into a point where if you did care about reproducing the input exactly, you may want to start doing more of an AST style approach where you actually produce the parse for the thing and just modify it in place so that you don't have to be having so much tracking of what you did and didn't see. So, it's hard to say how you want to go about doing that. There's a lot of different ways you could do it, and which one is the most efficient to implement largely depends on exactly what you want, as it always does. Everything's a trade-off. Everything costs more code, or takes less code, or is better, or is worse, and all so on. So if we don't want to do a rewrite, though, then what we do want to do is set the alignment point for this particular grid index. And so what we're going to be doing there, right, is we're going to be doing the excuse me, setting that alignment up onto whatever the actual import is that we do. So in here where we do the parse top level block, right, we're sort of processing this, and then we're looking at this, parse pieces sort of thing that happens. And what you can see here is this is a little bit too late to the party, right? We actually want to know what we're reading from a lot earlier than this. So what we'd like to do is be able to access at least this part of the information like way earlier than that, right? Like we want to actually start this process potentially a lot earlier than that, if that makes sense. Because what we want to have at this point is we want to have this asset source file. The reason we want to have that asset source file is if you look at what we're actually storing for the asset source file in here, it is the thing that actually gives us that translation table, right? So the thing in here, where are you, sir? The asset index array, this right here. This thing here is the thing that actually tells us where we would go to get those alignment points, right? Because here's the asset indices, and the asset is the thing that has the alignment points stored in it. So if we don't have this piece of information yet, we wouldn't actually know whether there are any of these things to set or not, right? We would have no idea where to put that particular piece of information one way or the other. And so what that boils down to is we sort of want to do the parse and get the data set up first, and then we want to call this actual function. Which again means we sort of want to reverse the order in which we're doing these things. Now, it requires us having parsed the tag arrays to do that. And the alignment points here, as you can see, is now something that it kind of creates an order dependency here that we have to figure out a way that we want to resolve. Because we would like to ideally parse these things first, and then when we load this stuff, they'll just get stamped on as we process those in place. But again, maybe we don't really want to do that at that time. Maybe we want to do that in a slightly different way, such as, for example, having the process multi-tile import side of things do the tag welding or who knows what else, right? There's ways we could imagine doing this so that we actually call this stuff first, and then at the end afterwards do the sort of stamping kind of onto the assets in arrears, right? Yeah, so again, it's really kind of hard to think about exactly how these things want to be ordered and how they want to be processed in that sense. But what I can say is that if we just want to cheese out for now, it's actually pretty easy for us to do so. And the reason for that is we can just parse this and remember it, right? That's really easy for us to do because, you know, if we want to, there's no reason that in here we can't just store up these alignment points ahead of time, right? Again, really, really simple for us to do, costs us almost nothing. And so when we're in here, what we can do is say, look, make a temporary structure. We know that we've got this many things to remember. So what we can say is like align points. And we know inside the file format that there's only a certain number of those that you can have. And so we can store all the ones we read pretty easily, right? We initialize it to nothing, so we know that there's none of them at the outset. And then when we read them in, we just store them into this array, right? At the location implied by the indices here. So when we get all of this information, we can then say, well, you know, just go to, and I don't know how these are indexed at the moment, whether we do grid X or grid Y, but I can look here. So it's YX, right? So grid X, grid Y, and then whichever one it is here. That's going to be our align point. So we can just say like HHA align point equals that one. And then the point itself can be set in specifically these ways. So I can say, look, I want to fill out all of the parts of that. So here's the P% 0. Oops. Here's the P% 1. Here's the size. And here's the type. And we can fill all of those fields out. Now, we want to put some error checking in here because they can put anything they want in here. So we want to first, before we set one of these alignment points, what we'd like to do is check everything for errors and issue errors where they occur. Now, if you imagined doing this piecemeal, you can imagine we'd need to do, if this thing is in range, then do the thing, otherwise error out. If it's in range, error out. And we want to have all those errors be specific. That's just a lot of typing. We don't really want to do that. So we'd much rather do something like, look, only put this in if we know all of our values are correct. So if we know all of these things fell within the tolerances that we expect them to, then actually proceed. Otherwise, bail. And then what we want to do is in here sort of upgrade this concept. So instead of require token and just having anything come back here, we want to have require number, and we want to actually have a range, right? So what we want to do here is say, look, we want to require, and furthermore, we want to require an integer range, right? So what we're going to do is say, I want you to give me a number back, and I want you to give me back that number. We can still return the token, I suppose. I want that number for grid X to be from here to here, right? Like I want it to fall between these two, right? And so this is going to be, again, coincident with this. So each one of these, instead of doing require token, is always going to be require integer range. And in here we'll just say, all right, that's what those two have to be. This one, same thing, require integer range. It's going to be between 0 and HHA bitmap align point count. So we've, again, like now we can issue proper errors to anyone who like put something wrong in there. And then finally, like these for size and P%, it's still exactly the same thing. It's just the integer range is much larger this time. But you know, it's still again exactly the same thing. So each one of these where you've got one of these requirements here, it's just going to be between 0 and the maximum for U16. Right? So again, we can read each of those in, and then we can go from there. Which of these ones we do, how we do each of these, we kind of need to be a little bit more specific about. We haven't quite handled type yet, right? But now each of these can be done with just this one simple function. Kind of makes it sound like one of those around the web things. This one simple function will get you all of the, I won't go down that route. Anyway, so what I can do there is, and I don't mean to do that, what I can do there is just, sort of duplicate my require token idea here and just add a second level to it, right? So I know that I'm going to get an S32, here where we get like one past max and min as a way of specifying a range. Maybe that. And so in here, I can do the same thing I was doing before, where I say, all right, let's get a token by calling require token. And I will say that it has to be a number, but then what I'm going to do is I'm going to check the range of the number. And so I'm going to say, look, we'll issue an additional error if this doesn't fall within the range that I expected. So first of all, if it does equal the number, because it might not, right? It could be that there was already an error with require token, and we don't really need to issue a second error, right? So assuming it was actually a token number, then what I'm going to do is check to see if it's within range, and if it is, good. If it's not, we will just issue the error. And maybe even clamp the value that's coming out of it, but I don't think we'll do that. So we'll just say, like, look, if it's a number, then let's check. So we'll then say, okay, if token S32 is greater than or equal to the min value, and token S32 is less than 1 past the max value. And I could have done where you actually pass the range in, but then everyone would have to -1 because you almost always want to pass the other thing in there. Oh, well, you know what? No, I'm wrong. Because here's the thing. We do actually want to allow that max value in the U16 max case, so maybe it's fine to just do this, right? And so you pass in a range here, and then what that means is that each of these just has to do, like, okay, the range is that range -1, because I don't actually want you to pass in the highest value because that would be out of bounds. It's fine. Okay, so, this is valid, and this is invalid. That allows us to print out a pretty handy error message, right? We're basically saying, look, we expected you to give us a number between here and here. You didn't, so go back to that place in the source file to figure out why you were trying to specify something that's out of the range of the possible things that we allow you to do here. And then we're good to go. So like I said, the only thing we don't have now is that type. I'm out of time, so I really shouldn't be doing any more. So we'll wind down pretty soon here, but there's your tire token range. So in here, if I just kind of jump to the other errors, don't ask me why we passed the token there. Possible loss of data for the S32 to, oh, that's fine, because we know they're in range. So these are all castable. So that's all good. And I think I'll probably leave the rest for next time. There is a few things we can do here if we wanted to. Maybe I'll do them really quickly. Let's just look. So if you look in here, there's this sort of align point name from type and align point type from name. And you can see that that would do the translation for us here. And so if you use any of these align point names, which are in here somewhere. Okay, so here. None, default, top of head, and base of neck, right? If you actually do those, we can actually translate them for you. And so that's probably what we would do there. So in here, we can do that checking. What I might do is say require type 0 to be that thing. So we might say something like this. Type 0 text, HHA align point type. And we would say that this is the base type, right? And we'd say if base type equals HHA align none, or I should say is not equal to that, then we know it was okay. Otherwise, it's not okay. And similarly, we need to do type 1 here and see what that would do. So in here, I can actually do it like this, I guess. So in here, oops. So in here we'd say like get that thing, get the type there and see if it's something valid. If it's not, then we would error out and say, yeah, no, that's not going to work, right? So this type 0 here, unrecognized alignment point type. And then the only other thing we have to do here is if we get this optional token, we may want to align, I'm gonna actually do it like this. We're gonna OR in here, the to parent. So we would in here say OR in to parent if it's appropriate. And so we're gonna want to grab that. Let me just lemon grab that out of here. And so we want to OR in that to parent in the case where this is valid, and if it's not valid, we want to issue an error again, right? So we want to do something like this, where if type 1, and I guess, do we have require identifier? We don't. So what I want to do here is say, look, I'm requiring identifier, and if the token, in this case, equals this to parent value, which I think we should just use as to parent, then we'll OR this in. If it's not, then it's an error because we don't allow any other modifiers to alignment points at the moment. And then we could just say like expected to parent and didn't get it, right? So I think that's really all we need to do there, and I think then we're done, right? So we've got all of that, and we build the type properly, and all that stuff is saved. And so that produces the complete list, which we can then do this processing here, and then we can, tomorrow decide what we're going to do at the end of all that. Now, I don't want to leave it in a non-compiling state, so all I'm going to do is just stub this out at the moment, and leave that as a to-do. So this is a not implemented right here. And we will pick it up tomorrow when we return. For now, oops. We will go to the Q&A. Let's see. There we go. And we'll address that later on. Looks like we got one more error in here. Yep. Well, you know what? We could just make this a U16 up here. Right? In theory. Okay. So even though this is returning something that has to be a U16, it doesn't think, I guess it's integral promoting it up, or what's the deal there? All right. It's probably because it assumes that enums are signed, and so it's looking and seeing that it's 8000 is the maximum value that's defined in the enum. And that means it can't store it in a 16-bit signed value, so then it goes and stores it in a 32-bit value? I don't know. Integral promotion rules in C, I never studied them, so I never know what they are. They're always bad, it seems. Like, I don't like them. But, they are what they are. All right, let's go ahead and go to the Q&A. Does anyone know, by the way, I can't... Inside the Twitch chat, if I do like QA, it doesn't work. Why do I have to go over to the Handmade the Handmade Network IRC to enter QA? Does anyone know why that is? Like, I have no idea why that is. How would you print an enum tag as a string in C? Well, you can't. That's why we have these ridiculous translation tables, right? C and C++, again, despite C++ having been developed for 30 years now, still can't tell you what the name of an enum is. They were like, I don't know how you could possibly do that. That's like technology so far beyond the C++ standard committee. They're like, we got nothing. We don't know. We don't know how we would give you back the name of an enum. That's like, I mean, Elon Musk can put a man on Mars, maybe, right? That might happen. But getting the name of an enum, what do you expect from us here, right? I mean, we're only the C++ standards committee. That's not the kind of thing we're ever going to be capable of doing. Like, we're still trying to learn how to use a sippy cup and ride a tricycle, right? So the answer is anytime you actually want to print one of these out, you have to make your own table. So you're constantly copying and making your own table. So if you look at something like how we do it, right, in Handmade Hero, we have to do it this way, where you go in here and have a little translation table that says what the names are from the various things that you've got. And it's terrible, right? Now, I showed on a Handmade Hero bonus stream, we don't do this in Handmade Hero, but I showed how to do it. You can write your own language augmentation, where you write your own preprocessor that goes through your code first and turns them into strings. Every industrial strength C programming house or C++ programming house has this. So like, I'm sure like the people who write like the Frostbite engine or whatever, they probably have a prepass that does something like that, right? Or the Unreal Engine probably has a prepass that does something like that. And that's basically because the language is so decrepit, it can't do it. Is there a reason you don't write bailout style functions to avoid too much nesting of if-else blocks? Yeah, so there is a reason. I like to have only one return point in my functions as much as possible. And the reason for that is because it makes it a lot easier for me to think about what is always happening and at the start and ends of routines. So it gives me an easy way to say, oh, you know what, anytime I go through this routine, like whether it errors or not, or whether this happens or not, I know it's going to go down here and do something, right? And each of my blocks shows me a new level of certainty that I've gotten to that I can also say, here's what would happen if I was unwinding out of there, right? And so I tend to just like things to be laid out that way. That's why I don't use, there's several things I don't use as a result. I don't use exception handling. I don't use goto to jump out of blocks like that. And I don't use if return style. I don't have a problem with any of those things. Well, exception handling's typically not very good for reasons that don't really have much to do with exception handling as a core concept. But so I might caution against that. But in general, I would say I don't have a problem with if return style programming. I just don't care for it. Would you be willing to use metaprogramming templates to do that job just because you absolutely have to? I'd be willing to use metaprogramming for it with an actual prepass that I write myself. I wouldn't be willing to use templates for it. Templates are so broken. I just don't. If I'm thinking to myself I need templates, I just write a metacompiler prepass. I'm always happier that way, because templates they're just awful. Synthusiast, can the difference between the pointers have undefined behavior? I guess we use it for the count variable. It depends. Differences between pointers don't have undefined behavior if they come from the same allocation, and ours do. So, meaning if you allocate a block of memory where you said, I'm going to have 10,000 characters in this stream, then you can difference. That's actually guaranteed by the spec. If you allocate two separate blocks of memory and then do a difference, I think actually technically if they are byte pointers, which a char star is, I think that may still be required to work. But if they were anything else, it wouldn't have, right? So if it was like, if they were integer pointers, then that would be undefined because the compiler is allowed to do any kind of shortcutting of the difference there. And while anything that's a power of 2 would probably still work, anything that's not a power of 2 might not work because the compiler may do shortcut math tricks assuming that they're both aligned to the same value since if they were in the same allocation, they would be, right? I'm probably not explaining this well. Let me say it a little bit more clearly. So let's suppose that we allocate a block of memory, and we have 2 pointers into the block of memory. If we ask the compiler to generate a difference between those 2 pointers, then it may want to take advantage of the fact that the pointers, because remember, difference between pointers in C is supposed to give you the difference in the pointers divided by the size they're pointing to, right? So if the things they're pointing to are 12 bytes long, let's say it's a struct with 3 integers in it, right? Then it can do, b minus a divided by 3. I'm sorry, divided by 12, right? And give you back that result. The problem is integer divide might be slow. So it might want to do it faster by recognizing the fact that if both of these things are known to be array indices off the base value. So if I know I allocated a block and I made an int pointer to the beginning of the block and I have an int pointer to the 3rd integer and the 16th integer. So they're both aligned to 4-byte boundaries, right? I'm sorry, we were talking about 12-byte structures. So each one is aligned to a 12-byte boundary because they're each, brackets blah. They've advanced that far from the front. The compiler may choose to output a sequence that generates a synthetic divide by 12 that only works if the values were all aligned to the original 12-byte values. So if instead you just have allocations randomly in space and they're not both aligned to the same 12-byte offset from the beginning, the compiler is allowed to generate code that just doesn't work. Not the way I would have spec'd the language, but that's the way they spec the language. How do you feel about guidelines encouraging coupling enums with guards and label arrays, static assertions on min and max of enum values, and macros to establish enums creating corresponding label arrays? I don't think I know what you mean by label arrays. I don't think I know what you mean by label arrays. Sorry, I can't really comment on that one. It may be just a term I'm not familiar with. If I understand right, Insobot only really echoes stuff from Handmade Network IRC to Twitch IRC. However, the mapping between Handmade Hero and Twitch is, I believe, hard-coded, so maybe okay, map the other way. All right. Well, that's too bad, but there you go. Regarding enum strings, would you be happy if you could write procedural macros to solve this problem? No. I want to just have it know what the It's obvious. Like you should just be able to say what's the string for one of these things. Like, I mean, that's a core. Introspection is like a core language feature. It shouldn't be something that you have to add to the language. It's like the most important language feature. I mean, I'm a metaprogramming centric kind of person. In my mind, that's like day one. It should be able to do that. Like, before it can even add two numbers together, it should be able to tell you what the name of an enum is in metacode. Like, that's more important than math. As a student who's being taught C++ in college, can you explain to me why you think it is a terrible language? Yeah, I mean, I've talked about it lots of times on stream, but basically C++, if you look at what I would consider kind of the core metric of a programming language, which is programming expressibility versus language complexity, it's a horrible language, right? It's absolutely massive. C++ is one of the largest languages in existence. I guess I don't want to say it's the largest language in existence because I don't know if that's true, but it might be the largest language existence. If someone out there is a computer languages person, could you tell me, is C++ the largest language? Because it might be, right? If it's not, it's up there, right? If you'd listed the top 10 largest specs, so that makes them hard to implement, it makes it harder to learn, it makes it difficult to really know all the rules, because even people who really think they know the rules of C++ often don't, right? It's huge, right? So it's up there somewhere. It's in the top 5, top 10 largest languages. It hardly is able to do anything. It has almost no features. Like we were just saying, it can't even tell you. Like, here's the thing it can't tell you. What are the members of this structure? You're talking about one of the largest languages in existence. It can't even iterate over the members of a structure. Like, they have added every single random thing that came into their heads to C++, and almost none of them are useful, right? And so it's just it's an incredible, it's almost like an exercise. It's remarkable, really, if you think about it. C++ has gone 30 years adding stuff all the time, adding huge amounts of stuff, and it's gained almost no actual useful features. Like, most of the features are critically broken or worse than the version that you would have just written in C. It's crazy. I just don't know how they ended up being so bad at it. So what you end up with is a language that has some good beginnings, because C was a good language at the time, but that every high-level language feature that you actually wanted got added in a totally broken way or not added at all, which is even worse, right? And so it's just a terrible language. It's impressively bad, and it's impressively bad from the standpoint of it's not that it's new, it's not that it's young, it's not that it hasn't had plenty of examples of how it could be made better, or use cases out there. There's tons of code that was floating around in C to look at. They just absolutely missed it every single time. Every single time. Off topic, what is your stance on compile time code generation like in D? Do you mean like the meta program features in like JAI? I am 100% for them. I don't program in D though, so I couldn't tell you. About label arrays. Arrays are the same size of the enum with strings corresponding to the label of each enum item for contiguous enums, or couples of labels and offset for sparse valued enums. Oh, okay. So going back to the original question then, sorry, I will reread the original question with that. How do you feel about guidelines encouraging coupling enums with guards and label arrays, static assertions on min and max values, and macros to establish enums, creating the corresponding label arrays? I do them sometimes. If I have lots and lots of enums and I edit them a lot, I will use a pound include with the enums in an INL file to generate both if I don't have metaprogramming available. So I do that sometimes. It's a little cumbersome, but it works. All right, I'm going to wrap it up here. Let's go ahead and get ready to stop recording. All right. Let's see. Thank you, everyone, for joining me for the episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code, so you're welcome to play around with it, do your own experimentation, and try out stuff inside the code base, which is a great way to learn in addition to watching the series. We'll be back here tomorrow when we'll try to get that translation process working, and that'll start our kind of debugging of the new sort of HHT-based import-export process. It's pretty complicated stuff. It's kind of a more proper art pipeline now, but we did a good job keeping it pretty contained, I think. And so hopefully we should have something tomorrow, by the end of tomorrow, that's somewhat reasonable, and then we can kind of look at cleaning it up. So hope to see you back here for that. Till then, have fun programming, everyone, and I will see you on the internet. Take it easy, everybody.